Welcome back. So, our third day on this, we're going to talk about three new concepts, okay? So, first of all, we're going to talk about something called a residual plot, okay? A residual plot is another way to determine if the data that or if we're looking at linear data or non-linear data, okay? So, basically here is the original, all right? So I want to label this as original for me since it doesn't really show it for you. This is the residual plot, okay? And what the residual plot is, it graphs your x values against the residual values of your data, okay? So what ends up happening is if your data is not linear, there's going to be a pattern here. Okay, so patterns are what you don't want to see. Okay, so you should also make a note of that is you don't want any patterns because if you see patterns in the residual, it means the original didn't was not linear to begin with. Now, what types of patterns are we talking about? Well, there's various ways that you can be kind of cautious about the residual plots. Now, this would be a good one. Okay, I'm not seeing any discernible pattern in that residual plot. Okay, all I'm seeing is scattered data. This one slightly concerns me. Now you may be wondering why. Well, it concerns me because the residuals are really close together at the beginning. You have small residuals, but then notice the residuals increase as you go across. Okay, you're getting more residuals, more spread there. So what that's telling me is my line is really good for small x values, but as x increases, it's getting less and less accurate. Okay, which again, we don't really want. This is another no-go as well. If you see kind of any curvature, anything like that, we're probably not going to want that. That's probably telling us our data was not quite linear from the get-go. Okay, so again, in residual plots, pattern is bad. Okay, so you need to make sure you make a mental note of that for yourself. Patterns equals bad when it comes to this. All right, so what about making a residual plot? Okay, so I can show you how to make a residual plot on your calculator. All right, so why don't you whip out your calculators with me? And first we have to input that data. So we're going to go to Stat, Input, and yes, I'm going to have to redo this data. So clear that, and let's type all of this in. 154, 207, 289, 437, 584, 683, 250, 265, 330, 375, 575, and 650. Now, in order for it to make the residual properly, I'm just really quickly going to run the linear regression because that's what stores that information for the calculator. So even though I'm not going to use this, I do want to run that, okay? Simply because now it has the residuals stored for me. So what do I mean by that? Well, what I want to do, not y equals, I want to go into stat plot, and a residual is a type of scatter plot, okay? So, excuse me. So I'm making a scatter plot with my x's, but instead of my y values, I want it tracking my residuals. Now, how do I get it to do that for me? Well, what I need to do is notice this command right here, this list command, if you go into list, residual is a secret list that gets stored whenever you run a linear regression. Okay, so this is going to basically trick my calculator into making a residual plot for me. Now, whenever graphing, remember zoom 9. And there is my residual plot. Okay. Now, residual plots, again, we're looking for no patterns. Okay. Now here, this one is a little questionable because it kind of looks like it starts and goes like that. Now again, with such few data points, it's really hard to get a good picture of this. So for this one, again, when looking at it, there's nothing too horrible. There's no distinct pattern that's telling me, this is really bad. Okay. So I would say, as long as R is fine, and as long as the scatter plot itself is fine, which we've already seen, this one I would say is a fine residual plot. It doesn't show enough of a pattern that would make me really question whether the original data was linear or not. If everything else were to support it, I would say that this is just fine. Okay, so again, just a skill, just another way to determine if you have linear data or not by looking at that residual. So today we're also going to talk about two other vocabulary terms, okay, to add to our repertoire of things we're going to be using to interpret lines. So next up is standard deviation of the residuals. Now again, the nice thing is you're not going to have to calculate this yourself, all right? If they ever ask you to interpret this, it is going to be given to you. And the general way that we do this, the standard deviation of the residuals, what it means is on average, it is how far the observed values are away from the predicted values, okay? So that's what the standard deviation of the residuals is measuring. It's measuring the spread of the residuals. So basically, on average, how far are your points away, or your observed points away from the predicted points? The other vocabulary term to know is the coefficient of determination, which is R squared. Okay? So what do we want to know about this? Well, this measures the percent of variation in the response variable that is accounted for by the regression line, okay? And yes, you see that this is R squared. It literally is the square of R, which we've already talked about, okay? So that is a very good association to make. R squared really is the square of that coefficient of correlation, okay, that correlation coefficient. All right, so let's chat about what does this mean, okay? So for the stock market example that we did, okay, we just did that yesterday. Let's say we know that S is 8.3, okay? S being the standard deviation of the residuals. So let's think of this format. On average, the observed value of blank was blank away from its predicted value by the regression line. So if that S value is 3 for that stock market price, so S being 8.3 means on average, an observed value of full year change was 8.3 away from its predicted value by the regression line. Okay, you're going to want to highlight this, star this, do whatever you need to. This is another one where you're just verbatim going to want to keep track of this, okay? You're going to want to memorize this because whenever they ask you to interpret this, this is what you should be doing for me. And what about R squared? Okay, so what about the correlation of determination? Well, let's go back and see yesterday's notes. So here is R. Okay, they gave us R in the problem. So again, quite literally, all we have to do is square R. Okay, and when we square R, we get 0.355 approximately. So if we follow this format, about 35.5% of the variation in that full year change is accounted for by the regression line. Now, this is probably one of the most difficult things about this test. There are so many different pieces that I need you to be able to interpret for me, okay? And again, that's kind of the hard thing is I can ask you to interpret slope, interpret the y-intercept, interpret now the standard deviation of the residuals, interpret the correlation of determination, evaluate interpret the correlation coefficient. There's so many different interpretations. You really, really have to keep them straight, okay? So that's one of the biggest things that we need to work on, just making sure that we know how to interpret each piece and we're very careful that we know what we're being asked for, okay? Which is why I'm keeping these notes really short, really sweet, because I want to give you plenty of work time to work on these examples, so make sure you can go back, look them up, make sure you're using the right interpretation, okay? So again, please, please, please make sure you ask if you have any questions. Otherwise, I will see you for the next video.